All right, let's take a look at a couple of questions from section, I forgot what section this was, I think it's 9.6. First of all, number 7. So they give you this isosceles triangle, so we know these two sides are congruent. We know the height is 15 decimeters, the base is 16 decimeters. And of course we know from earlier in the year, if you divide an isosceles triangle, if you drop an altitude into an isosceles triangle, you've got two equal sides, you've got a shared hypotenuse. Those triangles are congruent by a hypotenuse leg. So of course we're seeing all that proof stuff coming back from earlier in the year. So two congruent triangles means these two sides are each the same length. And notice we've got an 8, 15, 17 from the 15, 17 pattern. So, if you didn't notice that, of course, you could use the Pythagorean Theorem with 8 and 15, and you'd still get the right answer. But again, these Pythagorean triple patterns are really nice because they make these problems very fast. So they want the perimeter. So add up 17, 17, and 16, and I'll let you finish that. On to number 16. Again, lots of triples. Just start with the triangle that you have 2 out of 3 sides with and go from there. So we have an 8, 15, 17. We have a 6, 8, 10 triangle. You might not recognize this one. We've got a 10 and a 26. Divide out the GCF here. If you divide out the GCF there, you get 5. If you divide out the GCF there, you get 13. So this is a 5, 12, 13. Now remember, they're being doubled. So it's 10, 26. You're going to double that and get 24. Okay, and I think I drew the picture wrong here. I think the right angle on this other one is in another position. I think the right angle is actually right here. Otherwise, this problem doesn't work. Anyway, we have a something 24, 25. Remember, there is a 7, 24, and then the hypotenuse would be 25. So it looks like x is going to equal 7 on 16. Aren't these great? I love triples. They're wonderful. All right, 16b. A little bit more going on here. Let's see. We've got a side splitter set up here from last chapter. So, right, these are parallel lines because of the corresponding angles being congruent. So, of course, we know that 12 over 3 is going to be equal to y over 5. You could solve the proportion, but hopefully you notice you're just multiplying the denominator by 4. So 5 times 4 will give you a y value of 20. I would go ahead and fill that in because then you've got all the information you need for the last part. Now remember, this x value, that's not a side splitter, okay? That's a full side of a triangle, and we probably need to match it up with another full side of a triangle. I might have missed something on the labeling here. Let me just check real quick. Number 16, no, that's all they want. Okay, so what do we got going on here? So I thought maybe we'd be doing a comparison between these two sides and like drawing this triangle separately and the big triangle separately. Oh, check it out, it's a right triangle. We know the entire side is 15, and we know that entire side is 20, okay? They're both divisible by 5, so if you divide this by 5, you get 3. If you divide that by 5, you get 4. Oh, I'm sorry, this whole side is 25. If you divide this by 5, you get 5. So it's a little 3, 4, 5 triangle. So you're multiplying by 5, multiplying by 5, multiplying by 5 gives you 20 for x.